Next is example 4.20. This lab subjected to 3 parallel forces. We need to determine the equivalent resultant force and couple moment at origin O. Also, we need to find the location of single equivalent resultant force. So we have 3 forces, 400 going down, 100 going up, and 500 going down on the respective location as you can see here. So the resultant force at O is FRO equal to, for 100 Newton, direction on the K is going up, so 100K positive. Then 500 is going down, so minus 500K. Then for 400 is going down, so minus 400K, and we get our FRO is negative 800K Newton. Then we need to find moment at O due to these vertical forces. As you can see here, this is our axis X, Y, and Z, and this is our point O. So we start with 100 on X-axis with 3 meter, so times by 3I, then plus 500 Newton, so that one going down, so minus 500K. So this one not sitting on any axis, therefore to go to point O, it need to pass on 4 meter on X-axis, so 4I, then 4 meter on Y-axis, so 4J. Then for 400 going down, so negative 400, to get to point O need to pass 4 meter. This 4 meter is perpendicular distance, so times by 4J. So we get our moment at O. And always remember, moment is force times the perpendicular distance. Now we need to expand this MRO. First of all, we need to go for 3I times by 100K. So this is our 100. So we need to look exactly on here, our I on here. So this how it look like. So this is Z-axis, and this one is Z-axis, and it is 90 degree. So for 100 to get to point O, it will be clockwise to axis Y. Therefore, we can draw this direction into here, clockwise. Now hold the right hand rule on Y-axis, then thumb on the positive direction. Then we will have another direction here. So we need to compare both directions. So this going down, this going up. So we're going to have this direction, also this direction. So compare both that direction against each other. Therefore resulted in negative value. Therefore 3I times 100K, we will have negative 300J. So for this one, we can write it negative 300J. Refer back to our cross product in previous notes. For this circle, if we do have I, J, and K, if we going to get value of I times by J for this one, we will get positive K. However, if we go clockwise, for example, we take K times J, K to J, we will get I. But that is clockwise, so negative I. We can find for the others, for J times K, K times I times K, and J times I. And remember, for the vector cross into SF, we will get 0. Now let's back to 3I times 100. So I times by K will resulted to J. The direction is clockwise. So clockwise, negative. Therefore, here is negative. 3 times 100, 300J. Then we'll do the same for 4I plus 4J times negative 500K by using this circle. Let's check for 4I times negative 500K. So I times K resulted to J. So J direction is clockwise, so negative. However, we have another negative here, so result into positive. Negative times negative, we get positive. Next, let's check for 4J times negative 500K. So J times K, direction positive, we get I. So I, we have positive. However, here is negative, so resulted to negative 2000I. Using the same method, do for 4J times negative 400K. So J times K, I, and it's positive. However, here is negative, so we get negative 1600. Then we can get our MRO is negative 3600I plus 1700J Newton meter. So we find out our MRO and FRO. Then we need to identify location of the single resultant force due to 100, 400 and this 500. For that, we can use this formula for X and for Y. So substitute those value. For example, for MRY in Y direction, so 1700. So 1700. For FRZ, Z is K, so negative 800. So we get location on X is 2.1 meter. Then for Y is MRX. So our MRX, X is I, so negative 3600. Then our FRZ is negative 800. Therefore, our Y is 4.5. So we need to locate that location. So here 2.13 on X. So this is our X. So here is 2.13. And for our Y, 4.5. This is our Y. So this is 4.5 meter. Therefore, this is the location of the single resultant force with the magnitude of 800 Newton. So we find out our single resultant force and the location for that.